Global sea level contribution from Arctic land ice, 1971 to 2017. This new study reconstructs the year-to-year changes in the amount of ice stored on land across the entire Arctic for a 47-year period. Our approach uses field measurements of the balance of snowfall accumulation and surface melting, and in our case provide an annual measurement sequence from 17 locations across the Arctic. We make a simple yet robust mathematical scaling of the observed field data to satellite gravity data from the GRACE mission. The total loss of ice from Arctic glaciers, ice caps, and the Greenland ice sheet has averaged 447 gigatons of loss per year in the recent decade. If we divide the recent ice loss among the world's nearly 8 billion people, each person would get 160 liters of water each and every day of the year. The loss rate of Arctic land ice has increased threefold since 1986, from nearly 5,000 tons of water per second during the recent past to 14,000 tons per second in the present day. The present loss rate of Arctic ice is equivalent with 200 times the flow of the Thames River, or nearly that of the Mississippi River. Alaskan ice loss, roughly constant since 1988, is mostly from increased surface melting, despite marine terminating glacier retreat at places like the large Columbia Glacier. Arctic Canada ice loss accelerated around 1986, increasing sharply until 2013, which had a positive mass balance and resulting drop in cumulative sea level contribution. The increase in Canadian land ice loss, like elsewhere around the Arctic, is driven by increased surface melting from warmer summers. In the other Arctic regions, Arctic Russia, Svalbard, Iceland, and Scandinavia, they add up to about as much as the Arctic Canada sea level contributions. Taken together, the sum of these regions produce 23 millimeters of sea level contribution since 1971. The acceleration begins really in the late 1980s when Arctic climate is shown to have shifted to a warming pattern. Then from about year 2000 onward, roughly a linear sea level contribution because the rates of ice loss on Greenland and in Arctic Canada have slowed down a bit because of persistent atmospheric circulation that has brought cold air down the west side of Greenland at the same time that we've seen heat waves in Europe. We contend that our regional land ice volume change estimates represent the most accurate available prior to the 1992 start of satellite land ice height change monitoring. We show that the sea level contribution from Arctic land ice is 1/3 of the global amount since 1992, making the Arctic the largest regional source of sea level rise. Greenland alone, the largest source, represents half of the Arctic contribution to sea level rise. And year-to-year extremes in sea level contributions from Arctic land ice are primarily attributable to persistent extremes in atmospheric circulation, highlighting the atmosphere as a driver of regionally varying land ice changes in both space and time.